So I'm going to be working out problems 14, 22, 26, and number 30 from the homework that you were assigned. I'll start with number 14. I can already wrote it out here. So number 14 first asks you if this is a polynomial or not, and then it asks you what degree the polynomial is, and then you have to identify it as either a binomial or a trinomial. So first things first, this is a trinomial. One monomial, two monomial, three monomials, so it's made of three monomials, so this is a trinomial. So trinomial. Good. Then you have to figure out if this is a polynomial or not. If you remember, some of the rules were no negative exponents, none. No variables in the denominator. We have fractions, but all the fractions have constants in the denominator. Good. You can't have additions between the units of a monomial. Multiplication, division. Good. And then you can't have a variable as an exponent. That's not a variable. That's not a variable. Good to go. It is a polynomial. Doesn't break any of the rules. Yes. And the degree, well, first you have to figure out the degrees of all the individual members and then figure out which one's the highest, and that's the degree of the entire polynomial. This is a constant, 0 degree. Here we have a constant and a variable. The constant is 0 degree, so it doesn't really contribute anything. The variable here, the f, is to the first degree. It's a hidden first degree, but it's there. So this monomial is to the first degree. Here we have again a constant which doesn't contribute anything, but this variable, the f, is to the second power. So the entire monomial is to the second degree, and since this is the highest monomial in the entire polynomial is to the second degree. So that's number 14. Number 22, you're given two polynomials and you're adding them together. Well, first things first, you have to figure out if there's anything blocking you from opening the parentheses. There's nothing in front of that parenthesis, it's a plus, so good to go there. Nothing in front there. Perfect. You are welcome to break up this particular parentheses and start working here. Next up, you look at all the variables. Only h's. You can combine them, just find them. And then you start combining the monomials that have the same degrees. So here you have second degree, first degree, 0 degree. Second degree, first degree, 0 degree. How convenient. You can combine this and this. They're both second degree monomials. Then you can combine this and this. Probably should have included the sign in there. And then you can combine the last monomials, the 0 degree monomials. This and this. Alright, good. Now let's do some pairing. H squared plus 5h squared, then plus 4h minus 8h plus negative 4 plus 2. Good. All that's left is some number crunching and we're pretty much done. H squared plus 5h squared, that's 6h squared, plus 4h minus 8h, that's that's minus 4h, that's going to be a negative 4h, and then plus negative 4 plus 2, that's also going to be a minus 2. So 6h squared minus 4h minus 2 is the final outcome. So this is our new polynomial. So this is the result of you adding those two polynomials. This is the sum. So this was 22. Next up, we are going to go ahead and do number 26. Alright, so number 26, again you have a pair of polynomials and this time they're being subtracted. So before you can do anything else, you have to take a look at the minus sign over here. And it prevents you from opening up the second parenthesis. You have to distribute that before anything else can happen. So you have to distribute that evenly to every single member of that second polynomial. Alright, no problem. So I'm going to rewrite both of them just so it's easier to see. So I'm going to rewrite the first one, because that doesn't change. And then I'm going to go ahead and distribute this and open up that parenthesis. So it's going to be a minus 4x to the third. I could have probably just opened up this parenthesis too, but I already wrote it that way, so because there's nothing preventing us from opening this parenthesis. Anyway, so minus times 4x to the third, that's minus 4x to the third, minus times a positive x squared, that's minus x squared, minus times a negative 15x, that's a positive 15x, minus times a positive 1, that's a negative 1. Alright, now that's done. Again, the parentheses here, nothing stops us from breaking them, so we're going to ignore them. Now we're going to go ahead and combine anything that has the same degree. So let's start with anything with a third degree, because that's the highest degree in the second polynomial. I see something with a third degree here. I see nothing of that kind in the first polynomial. It's going to be a loner all by itself. Now let's take a look at the second degrees. Second degree. Second degree. These guys are going to pair up. Now let's look at, I forgot an x here. Let's look at first degree monomials. I see one here, I don't see one there. So we have another loner. It's going to go here as a loner. And then last, 0 degrees. We have a 0 degree monomial here, negative 8. Another one here. So these guys are going to come in right over here. Hopefully you can see my highlighter. Alright, once all that is said and done, I'm going to do my pairings. So my lonely third degree monomial with no counterpart just goes here by itself. Then we have my second degree monomials. So 3x squared minus x squared. For the first degree, I had just the loner, the 15x, no counterpart here. And lastly, for my 0 degrees, I had a negative 8 minus 1. Okay, terrific. So now I just do some number crunching. This stays because, well, there's nothing we can do. Plus 3x squared minus x squared, that's 2x squared. That just comes down. Negative 8 minus 9, that's, sorry, negative 8 minus 1, that's minus 9. So that's my new polynomial that I got by subtracting the original polynomial. So there was a difference there. I worked it out, and this is my new polynomial. Alright, next up I'm going to do problem number 30. This is the last problem that I'll do. Alright, so this is problem number 30. Again, I have two polynomials. This time it's addition. First things first, look in front of the parentheses. Can I break them without doing anything? Positive here, good to go. I can ignore the parentheses. Next up, I'm actually not going to do the pairing method that I did with the last two problems. I'm actually going to do the stacking method to show that, where you can stack one on top of the other. So first of all, I'm going to look and see if both problems are in standard form. For the second one, third degree, second degree, 0 degree, yes, standard form from highest to lowest. Over here though, I have second degree, third degree, 0 degree, and first degree. That's pretty bad. So I have to do some rearranging. So I'm going to write the first polynomial in standard form down here. So the negative 6p to the third has to go first. It's the highest degree. Then comes the second degree, the 9p squared. Then comes my first degree, which is the 11p. and the plus 3 is the 0 degree, it's last, and then plus of that, of course. So now I'm going to go ahead and stack them. Now that this is in standard form, I'm going to put this first, I'm going to put this underneath, and I'm going to add them together. Now, important fact, I can't put the 4 here. Here goes the first powers. There's nothing here that is of a first power. So I'm just going to write down plus 0 as a kind of like a placeholder. And then plus 4. You don't have to write anything, you should leave it blank too. It won't really make a difference. But this is why it's important to make sure before you do the stacking method that both polynomials are in standard form. Because if I were to put this as is and I was to write this down underneath it, I would have the 7p third and the 9p squared kind of lined up, and that would be very bad because you can't do anything with a second degree and a third degree monomial. They have to match degrees. That's why I had to change this first before I stacked them, and over here I had to kind of stagger the 4 over. I couldn't put the 4 underneath the 11p because the 11p is first degree, the 4 is 0 degree. I have to put the 4 with the 3. They're both 0 degrees. So there was nothing here, so I'm just putting a 0 there. You can just leave it blank, whatever works for you. Just make sure to stagger that. So negative 6p to the third, positive 7p to the third. That's just 1p to the third, or just p to the third. Negative 9p squared, sorry, positive 9p squared minus 3p squared. That's going to give us a 6p squared, positive of course. And then negative 11p. The other polynomial didn't have a counterpart, so it literally just comes down. I honestly rather not even put the 0 here, just leave that blank. And then plus 3 plus 4, it's a plus 7. That's it. That's your brand new polynomial made from the 2 previous polynomials. Again, the important thing here was to put this one in standard form, as I did here, and then when I was stacking the 2 together, I made sure to stagger the 4 from the second polynomial over one space because the second polynomial didn't have a first degree counterpart. It didn't have a counterpart for the 11p. So again, I prefer actually that you leave it blank. Don't even write a 0. Just, you know, just put a space in between them. The 11p would have just, or the negative 11p would have just come down, straight down. Alright, so that was number 30. Thank you very much.